Hey guys, the previous video explored the half-life calc for a first order reaction, but what if it's second or third, or zero order reactions? Well, we can derive those too just as easily. Let's say it is a second order reaction. So for a second order reaction, right, the integrated rate law is 1 over A at times T is equal to KT plus 1 over A naught. And if we manipulate this, we could do kind of what we did before in the other one. We want to get A naught over AT. So if we, let's see, bring these guys over to the same side of the equation. 1 over A sub T is minus 1 over A naught is equal to KT. Now if this is the case, we're going to substitute AT, right, is 1 over A naught times 2. So let's go ahead and do that. So what we just did right here is we just derived the half-life equation for a second order reaction. We simply plugged in A naught divided by 2 and then consolidated all of the terms. Could we also do this for the zero order reaction? You bet. Let's try that one. The integrated rate law for a zero order reaction is A at times T is equal to minus KT plus A naught. If we do what we did again, and we substitute A at times T for A naught over 2, and then we bring this guy over to the other side, minus A naught, we now have minus equal to minus KT. So A naught over 2 minus A naught is equal to, well, let's see, let's clear that 2 and multiply everything by 2. If we multiply everything by 2, both sides, we get A naught minus 2A naught is equal to minus 2 KT. We fly up here. A naught minus 2A naught is minus A naught. And that's equal to minus 2 KT. Well, if we divide both sides by minus 2, that becomes A naught divided by 2K, and that's equal to the half-life for a zero order reaction. So there's different ways you can approach this. You have to know what this right here, the half-life for a zero order reaction, that's T1/2 for zero order, and you also have to know the T1/2 for a second order reaction. So you can do one of two things. You can memorize these values, or you can sort of do what I do and memorize as least as possible and figure out how to derive them. It's up to you. And that's how you get second and zero order half-life equations.